Hello and welcome to another video. In this video, we're going to be solving find the number of ways to place people 1 and 2 from the Biweekly Contest 123. 1 and 2 are basically the exact same problem, just a tougher constraint on number 2. So we'll go through like how to do the first one and what optimization you need to pass the second one. So here, you're given a 2D array of points of n equals 2, representing integer coordinates of some points on a 2D plane, where you basically have points that are x and y. And they kind of just describe a bunch of stuff that's kind of irrelevant, so I'll explain it a little bit easier. You basically have an XY grid and a bunch of points, and you can build rectangles on this grid, rectangles on this grid using 2 points. So essentially what they kind of ask you to do is using combinations of 2 points, where one point is the top left of a rectangle and the other point is the bottom right of a rectangle. How many rectangles can you build such that there are no other points in the rectangle? And we'll get into the examples. But if we take a look at this, like this would not be valid because one of the points has to be the top left, and one of the points, let's use another color, and one of the points has to be the bottom right of the rectangle. And there can't be any other points in the rectangle. So there's a bunch of points, you can only use combinations of points with no other points in there. So like this wouldn't be valid because it has to be top left and bottom right, and this wouldn't be valid either because it has to be top left and bottom right. And yeah, so let's go through the examples, I'll make it a little bit easier. So here are points here. So using these points, we can't build any rectangles that one of the points is the top left and one of the points is the bottom right, because if we use 2 of the points, it'll always be something like this, where the points won't be top left and bottom right, they'll be bottom left and top right. So there's nothing here. So they show you the second example with these 3 points. So this is like a valid rectangle right here, where you have a point on the top left and you have a point on the bottom right. And this point is not in that rectangle. And you can't build a rectangle like this, they show you, because there's a point in that rectangle. So this one is invalid. This one is also valid as well using these 2 points. So you have two combinations of points. That's basically what you need. How many combinations of points can you build rectangles where one's on the top left, one's on the bottom right, and no other point is either in the rectangle or like on the border here. And let's go to the last example. So they also do tell you that you can build rectangles with 0 area. So you can have a point on the XY plane where the left point is on the left and the right point is on the right. This is valid. You can also have a point on the y-axis. So this would be on the x-axis, this would be a point on the y-axis where the first point is on the top and the second point is on the bottom. So they do tell you that. This is fine. But you can't build like this because you have a third point on the rectangle. So this would be invalid. So we can formally write basically for our points. So point 1 has a value of x1, y1. Point 2 has a value of x2, y2. So they tell you points have to be identical. So x1 has to be less than or equal to y1, x2, and y1 has to be greater than or equal to y2. If that's true, then you can build a rectangle here, right? So like, let's go back to this example here. This is x1, or this is point 1, this is point 2. So x1 is less than x2, and y1 and y2 are equal, that's fine. And here, this is x1, or this is point 1, this is point 2. So y1 is greater than y2, which is valid. And here, this is also valid, but this point does not work. So you can't have points like let's go back to another example. Let's go back to this first one. Here, this would never work, right? Because if you use this point and this point, x1 is less than x2, but y1 is less than y2, which is not valid. So basically, just to make it a lot simpler, you can either build rectangles with a point on the top left and bottom right, or you could build these lines where the left point, if it's an x-axis line, the left point has to be on the left, the right point has to be on the right. Or if it's a y-axis line, the first point has to be on the top, and the second one has to be on the bottom. These are both fine. But let's say you did have a point here, then this wouldn't be fine. So even you can build the line, but you have to make sure there's no other point on this line. Or if you build a rectangle, there can't be a point in the rectangle or on the out perimeter of it. So the brute force of this is pretty straightforward. Basically, given a bunch of points, we're going to show like a grid here. Let's say we have a bunch of points. And let's kind of represent an XY axis. Maybe like this can be it. So this will be like an XY grid. And then let's say we have a bunch of points. So maybe we have a point here, And I think that they all have to be positive. No, they don't have to be all positive. You can have negative points, looks like. But that doesn't really matter, right? Like if a point's negative, it's still kind of the same thing. So let's have a point here, maybe a point here, and so on. So let's take a look at like what points we can use, right? So like how can we make a rectangle? Or one of the ways we can obviously make a rectangle, to actually maybe make a rectangle, is like this, right? Like this would be totally valid. There's a point on the top left, bottom right, and there's nothing in this. So that would work. Another way is you can have something like this, right? Like this would, if you have these 2 points, this would be fine, right? Like that would be totally fine. And there's nothing in this like thing. Another way would be maybe like this. Another way would be, I mean, there's a bunch, right? But essentially you kind of get the idea, right? So basically the way to do this is we could just manually go through all sets of points. So like, let's say let's actually mark these, let's give these some numbers to make it a little bit easier to show like what we would do. So let's say this is 0, 0, this is like 1, 2, 3, 4, -1, -2, -3, -4, and then 1, 2, 3, 4, -1, -2, -3. And we can just go through like all combinations of points. So let's say we pick like these 2 points here, right? Like this point and this point, and we'll just check, is there a third point that is in this square? So we can figure out like, okay, well, what's the x, what's like the dimensions of the square? And then we go through every other point and just check, is it in there? And if it's not in there, then this is valid. And if it is in there, then this is not. And we can do the same for any 2 combination of points. So the same thing here, right? And basically the way you would do it is, let's say you have point 1 and point 2. So point 1, point 2. So remember, point 1 has to be on the top left. So point 1 will have an x1 value and a y1 value. And point 2 will have an x2 value and a y2 value. And so if there exists a point where that, or we can call it like this, that has x3, y3, if x3 is in between x1, is x1 and y, or x2, right? If it's in between those, and y1 in between, or whatever's bigger. So in this case, remember y1 is actually bigger than y2 here. So y1, it's actually going to be like this. y2 is less than or equal to y3 is less than or equal to y1. So if there's a point here, that means it's in the square, right? Because we know that x1 is less than or equal to x2, and y1 is greater than or equal to y2. We defined that earlier because we need the first point to be the top left, the second point to be the bottom right. That's the way to do that. So like, for example, here, if they are the same, y1 has to be greater than y2 or equal. So if you have to pick here, this will be 0.1, this will be 0.2. So let's just go through like maybe this example. Like let's say we pick these 2 points. So for these 2 points, let's write down the x1 and x2 and y1 and 1 and so on. So we have x1 equals, let's see, -4. x2 equals -4. And then we have y1 equals 4 and y2 equals -3. Now we basically need to find a point where like that point is, in order for it to be between these two, it basically has to lie on this x-axis. So its x value has to be -4, and its y value has to be anywhere between 4 and -3. And we just go through our points, find if something exists. So here's our point. No point has that, so this would be one. This would be fine, right? Then we can go through some other point, the same kind of way, right? We basically just do like a nested for loop where we compare 2 points. So let's do a couple more points just to show this. So let's say, for example, we pick these 2 points. So here, x1 is -4, y1 is 4, x2 is 4, y2 is -3. So we basically have to find a point that has an x value between these two. So anywhere between these two, -4 and 4, and a y value between these two. So anywhere between these. And we do have a point here, right? So this point has x value -4 and y value -3. So the x value happens to be in this range, and the y value is also in this range. This point, the x value is also in this range, right? So the points we're actually picking is these two, right? These two. So this rectangle would actually have multiple points in it, and we can see that, right? Both of these points are in the range. So this point would also be in the range, the x value is in the range, and the y value is in the range. So these 2 points wouldn't form a valid rectangle, but these two, like I said, you can either have a rectangle or a line, but these two do. And you basically just go through all combinations. So you just have like an n-cubed solution where you just have like a, pseudocode is like go through all combinations of points and then check if the 2 points are valid for top left and bottom right of rectangle. If yes, then go through rest of points and see if anything is in that rectangle. So pretty easy. And you basically just, when you go through your points, to make sure you avoid duplicate combinations, so you can go through like all your points, and you can just make like if you have an ij loop, you can just have like the first point try to be the top left, and then the second point tries to be the bottom right. And if that is the case, by just comparing like where the x and y values are, like we talked about that already, right? For what has to happen, where like x1 has to be less than or equal to x2, and y1 has to, so basically this right here has to be true to have a valid top left and bottom right. If that is true, go through every other point and check if it's in there. So we can actually look through the code. Let me see which one that is. So I think it's actually over here. Let me pull up the medium solution. Here it is. So yeah, this is, oh, and that's not the one, sorry. So it's actually going to be, if we click here and we go over here, there we go. Okay, so this is basically it. Pretty straightforward code. So you basically just go through all of your points. If they are the same point, continue, get an x1 and y1. If these things aren't valid, remember x1 has to be less than or equal to x2, and y2 has to be greater than or equal to, or y2 has to be less than or equal to y1. If that's not the case, just go to continue. If that is the case, just mark it as true, right? So you just mark it as true, and then can get rid of this libraries thing. And we basically have a variable mark as true. Then we go through every other point, and we do this thing that I said. So if x3 is less than or equal to, or is greater than or equal to x1, and it's less than or equal to x2, and all these things, basically if that point is in there, kind of like what I showed or in here, basically this right here, then that point is in the square, and if that point is in the square, then we mark that combination that we found not valid, and we break the loop. Then after we checked all of our points, if it's valid, then we just mark that combination as valid, and we return. And in this one, the constraints are small enough to where n cubed is fine. So here is only 50. So 50 cubed would pass. So if we actually run this, this is fine. And I was trying to find an optimization here, but like I was like, I'm pretty sure I can make it n squared somehow, but I'm not too sure how. Like it's probably it's a medium problem. How hard can it be? But it does make a little bit of sense that the optimization is actually like the hard problem. I don't think it's too hard, but yeah, it's not like super simple. So let's kind of talk about where we go from here, from this O of n cubed brute force, where we just find 2 points that we try to make a rectangle and a third point that's in there. How do we find an optimization? And so the way to find an optimization is, notice that we can just, like, for the x and the y, like the first point has to have a smaller, or let's actually get rid of all of this. We don't need this. So notice for point 1, x has to be smaller or equal to x2, right? So point 1 has to be this. And then the y for point 1 has to be greater than or equal to y2. So we can actually just sort our points by this kind of methodology. So we can sort our points in increasing order in X and decreasing order in Y. So if we did have a bunch of points, like let's say we had a bunch of points that that look like let's actually see if I can do this. Nope. Okay, so let's say we had this point here. Let's say we had a point here. These points sorted would be, this one would be first, right? This one would be second. This one would be third. They'd have the same Y value. But also if 2 points were the same on the, 2 points were on the same like Y intercept, then we want this one to be first. Because we're basically going to store for a point what's like the closest point to it. And what I mean is like, if our points are increasing, that means that, so if our points are increasing, that means that any point between 2 points, so let's say we have points like at index 0, 1, 2, 3, 4, 5, and so on. If the points we choose to pick, we're going to be picking points with points down the road. We're not going to be doing an n cubed thing anymore. So our strategy is going to be like, we're going to pick one point as the top left, and then we're going to try to go through the rest of it for the bottom right. So what I mean by that is like, let's say we pick 0 for the top left. That means we're going to go through this point, this point, this point, this point, this point, this point, and try to pick them as the bottom right. But notice that if all these X values are increasing, that means that if I'm comparing 0 and 3, all the points in between those are always going to have an X value that fits in the rectangle, right? Because these are increasing. So like this, like let's say this X value is like 0, this X value is like 5. All of these X values are going to be in that range, right? So because we sorted them in increasing order. So the X value will always be in the range of the rectangle. Now we just basically have to check, is the Y value of any of these points also in the range of this rectangle? And the way we're going to do that is we need to really figure out how do we store something efficient to tell us if the Y value is in the range? So let's kind of explain how we would do that. And it's not super hard, I think. So basically, let's say we're picking this point and we're comparing it to like this point, this point, this point, and so on, right? When we compare it to other points, like what do we want to store? Well, we want to know if the Y value, if there's a Y value between this point and the rectangle it makes. So let's say we're trying to like make a rectangle like this. We want to know, is there a Y value out of the points between this point and this point? It has to be between these, right? Because any other Y value doesn't matter. That's the other thing I forgot to mention. So if we're comparing 0 and 3, all of these will have an X value outside of the range, so we don't really care, right? Actually, they won't have an X value outside of the range, but if the X value is in the range, the Y value will be outside of the range. Because we're going to be sorting X's in increasing order and Y's in decreasing order. If we have something like this, where X's are, let's say we have something like this, where X's are the same. So we compare these 2 points, like 0 and 5. So if these are the same, that means the next value will have a smaller Y value than these two. So it'll be like 0, 2 or something. Or the X, so the X value will either be the same as this, and the Y value will be smaller because we're sorting the Y's in decreasing order, right? So it'll be something like this, which is outside of the range because our line would be like 10 to 5. And then this point would be below it. So that would be outside of the range. Or the Y might be in the range, but the X will be outside of the range, right? So the point after the two we're comparing will either have an X value outside of the range or a Y value outside of the range. So all of these points will always be out of the range if we sort like this. So now that we know that, what we really want to, like what do we want to store for the points that are in between these, right? So if we are going through X values, like let's say we start with these X values first, and we're going to like do some stuff. So for example, let's say we're trying to make a square. Maybe let's get rid of this point if I can. Okay, let's pretend it doesn't exist. I think I can probably just draw a line here. This would be good enough. Okay, good enough. So yeah, so the way we're going to compare points is we're going to be comparing them. We're going to be comparing them in increasing X order. So like we'll compare this one to this one, and notice how all the points after that, right? So this will be like 0.0, 0.1. This will be 0.2, 0.3, 0.4, because the way we have it, right? It'll be increasing in X, and then when there's a tie in X, the bigger Y will go first. So when we compare points, remember the left point is going to be the top left of the rectangle. So the rectangle is always going to look like this or some kind of rectangle. So what point, like, and I'll notice this rectangle is always going to go down, right? It's never going to go like this way. Like this point that we pick is the left is always going to be the top left. So it's going to be like this, like this, like this, or something. So what y value do most of, like, what's the most common y value in between all these rectangles? Like, let's say this rectangle, what y values do all of these share? Like this one, this one, this one, and so on. And so the trick is you want to store the y value that's closest to this left point that is lower than it. Because let's say we store this y value, this like 3. Now most of the rectangles, and remember this 3 is going to be all, like the x will always be in range. So we're going to store like this whole y value basically. Now notice how many rectangles that we make out of this will have this y value. Like any rectangle that goes at least 1 down, this y value will be in the range. Right? Where if we stored this one instead, if we stored like 1, now there's a lot more rectangles you can make that don't have it in the range, right? You can make this, like any one of these. So that's kind of the idea. As we go through, like once we start at a value, like let's say we start here, as we go through everything else, we're going to store the y value that is below this. It has to be below this, right? Because any y value that's above will never be in the rectangle, because the rectangle will always be going down. But we want to store the y value that's closest to the value of our top left point. And remember the x, because this is sorted in increasing order, the x for all these will always be in the range. Then we can just check for this y value, is this y value less than the y value we stored or equal to? And so if the y value we stored is like here, and we're trying to make a rectangle over here, then we can't do that, right? Because this y value will be in the range. So we know the x is in the range, and the best y value to store is going to be the one that's closest to this point. So I guess we can kind of like do a little dry run of these, or at least some of these, and see what happens. So this will be our first point. We won't have a y value yet. We are going to compare it to this, right? So remember, our points will be sorted like this, where this is 0, 1, 2, 3, 4. So we're going to say, okay, it's sorted. So we're going to start at point 0, and we're going to compare it to point 1. We don't have a y value. Is this rectangle valid? Yes, it is, because this point is like below and to the left and to the right. And do we have a y value that's in here? No, we don't. So this is 1. So that is a valid rectangle. We're going to put 1. Now, what y value do we want to store? Remember, we're going to store the y value that's closest to this, but it's going to be out of all the y values we've seen so far. So right now we've only seen 1, so we're going to store -3. At first, we can just initialize it to like -infinity or something. So we've seen something that's valid that's 1 time, and our y value that we're storing is -3. Then we're going to compare 0 to 2. Now 0 to 2 is, you can't make it like this, right? So this is invalid. And we don't want to store 2. We don't want to store this y value, because this y value will never be in a rectangle with 0, because remember the rectangles go bottom right. So now we're going to compare 0 to 3. Here it is. So 0 to 3, that does make a valid rectangle. Now, is our y value in this rectangle? It's -3. So it's outside of this range, right? It's not between 4 and 3. And we can do this in O of 1. It basically has to be between these two. So it's not, so this is a valid rectangle. So we're going to add 1 to our rectangles. And now remember, we want to store the y value that's closest to our point here. So our old value is -3. Now we have 3. 3 is closer. So we're going to store 3. Let's actually get rid of this rectangle real quick. So we're going to store 3, and we have 2 rectangles. And now we compare 0 and 4. Does this make a valid rectangle? Yes, it does. Now, is the y value that we have stored, this value over here, we have a 3 stored, is that in between this top and bottom? Yes, it is, right? Because it's 4 and -3. It's in between those, so this can't be valid. And that value is better than this one, so we're not going to get rid of that. So now we went through all rectangles with 0 as the top left corner. Now we'll go through all rectangles with 1 as the top left corner. So now we don't have y value anymore. So for 1, we're going to compare it to every rectangle after it, right? So because the rectangle has to go this way, we only have to compare it to rectangles after it. So we're going to compare 1 and 2. 1 and 2 doesn't work because it's not going up. So 1 can't be like the top left corner of 1 and 2. 1 and 3 doesn't work either. 1 and 4 does work. We can make a line, like I said. So this is valid. Do we have a y value in this range of just -3? No, we don't. So this is a valid rectangle. And this is going to be like the best y value to store now, right? Because this is as close as you can to 1. So now if you have something here, you're never going to be able to make another rectangle, including like, you're basically never going to be able to make another rectangle because this 4 will always block it, right? With this 1. Like every x will be bigger. So no matter what rectangle I make here, it's always going to have this, like this value over here. So now nothing works. But that's why we want to store let's get rid of this. Yeah, that's why we want to store this y value. So this y value would be 4, and then this would be 3, and now there's nothing after 4. So now we have rectangles with 2 as a start. So we get rid of the y value again. We just reset the y value every time we get a new point for the top left of the rectangle. So we compare 2 and 3. So is 2 and 3 valid? Yes, it is, because the y value for 2 is greater than 3. Okay, so this is valid. So we will add 1 to the rectangle. And what's the y value we should store? We should store this 3 here, right? Because this is the only one we have. So we're going to store 3 for the y value and update this to be 4 now, 4 rectangles that we found. Then we're going to compare 2 and 4. Is this a valid rectangle? Yes, it is. Is 3 in this range, or is the y value, not 3, is the y value we have stored in this range of, so this is 5 and -3. Yes, it is. It's 3. It's within that range. So we can't have this rectangle. And is this, so I guess whenever we can't have that rectangle, the y value will never be like better. So we just keep the old one. Okay. So we did everything with the 2. Now we're going to reset this again. And finally, we have one more rectangle of 3 and 4. And so is that a valid rectangle? Yes, it is. Is there any y value in the range? No, there's not. There's nothing. So we update this to 5. And what's the y value here? This is -3 because it's the only one we have. So that's kind of the trick here is whenever you make these rectangles, you just store the y value that's closest to the top left corner, but has to be less than or equal or below it. You never want to store anything above it because that'll never be in a rectangle. And that will get your solution from oven cubed to oven squared. So we can look at that one right here. And here it is, pretty simple. So you basically sort your points, and this is how you make a sorting function in Python. Increasing x, decreasing y, you can make a lambda function. You just make the first value will be positive, the second value will be negative. Then you just loop through everything. So you basically just make you get a y value that you want to store, right? And this is the y value that we want to store. I don't even know if I use this y, do I? I don't think so. I don't see that I'm using it. So I think, yeah, I don't think I need it. Oh, apparently I did. Where am I using it though? Oh, right here. Okay. Yeah, so you do have a y value. Let me just double check why that is. So for this is the length points, we get a y value. So the y value is actually, oh, I see. I just got the y value out of the point I'm currently on. So this is the y value that's going to be the top left corner of the point we're currently on. This y3 is going to be the one that we're going to be storing and changing. So we have the nested loop where we look through every point past this point, and then we get a y2 from there, which is the same thing. And we just check, is the y value that we stored in between those 2 points? So basically it has to be not in between those 2 points. So y has to be greater than or equal to y2 in order for this point to be the bottom right, and y3 has to be less than y2 for this point to not be in the rectangle. The x will always be in the range, like I said, because it's increasing x's. So if y3 is outside of the range, then we can add 1 to the result. And then if y3 is outside of the range, that means we have a valid rectangle, and y3 is somewhere like down here. So whatever point we're on currently is going to be the best point to store. So we just store that. And yeah, and then we just update the rectangle. So this becomes of n squared. And even though you sort, it doesn't really matter because you have an n squared function, so sorting is like free. So this is going to be of n squared. And it'll be actually faster, right? Because in our old function, we were actually checking every point to every other point, where now we are checking every point to only points after it. So it's really kind of like n squared over 2, even though it doesn't really matter in big O, obviously. So this is going to be time of O of n squared and space, it'll be O of 1. So definitely a lot easier than most 7-point problems. Most 7-point problems usually, or 8-point problems, take me around an hour or two. They're usually very, very complex. I think this one's like not too bad. You just basically figure out like what greedy y value to store, and then it's kind of easy. So I think this is more like, yeah, like this should be like a third problem of the contest, to be honest. I don't think it's harder than like the third one that we had here. And yeah, we can try that, and you can see it's pretty good. And like the way you can tell usually is normally for the 7 or 8-point problems, they have a very low acceptance rate. This one has like 50. Obviously, people can like copy the solution, but still, like normally they have like 10% or less. So yeah, definitely a lot easier. And this is definitely a contest that if you are trying to finish them, I think this is one that most people could finish pretty reasonably. And yeah, that's going to be all for this one. Hopefully you liked it. And I think that's going to be all for this contest. So I'll make the videos for the next contest within the next few days. So yeah, if you did like this video, please like it and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.